So we'll get a better handle on accuracy, precision, uncertainty, and significant figures in the laboratory. But briefly to cover it here, accuracy is going to be how close you are to an accepted value. So if you go into the lab and you start measuring the acceleration due to gravity, how close are your measurements to the actual accepted value of something like 9.8 meters per second squared? Okay. So that's accuracy, which is a little bit different than precision, which is how close your measurements are to each other. So if you make a bunch of measurements of the acceleration due to gravity, the precision describes how close those measurements are to all of the other measurements you make. And then finally, the uncertainty is how well you can do your measurements. Okay, how accurately can you measure something? And this is all determined by the tools you are using. How well you can measure is determined by how good your measuring tools are. So if you have a ruler, you can't really measure down to thousandths of a millimeter. You just can't state that kind of precision. And the way that we denote this, okay, is going to be with significant figures rules. You get more practice in all of this when doing your first few labs. But in general, Sig Figs, there are a couple of rules we can follow for counting Sig Figs and knowing how many digits in our answers or measurements are significant. So what you do is you start at the left side of the number and count the digits. The number of digits you have are the number of Sig Figs, with the exception of zeros. Zeros kind of make things a little bit confusing sometimes. So with zeros, placeholders are not significant. So what does that actually mean? Placeholders aren't significant. So if I were to write a number, if I were to write the number something like 1300, these two zeros, these are placeholders. Okay, they're showing kind of not accuracy necessarily, not how precise your measurements are. So this number would only have two significant figures. And this can get very confusing and very weird. So the reason, the way that we can kind of counteract this potential confusion is to use scientific notation. So if I wanted this number to have two sig figs, I would write it as 1.3 times 10 to the third. Okay. Then I clearly have two digits, digit number 1 and digit number 2. And these zeros that kind of come at the end, these aren't confusing at all. I know if they're significant or not. If I wanted 3 sig figs, I could write this number as 1.30 times 10 to the third. Okay. So this 0, it's not a placeholder, right? There's nothing in between. It's not holding the space between two other numbers. This 0 is significant. If I wanted 3 sig figs, I could write it 1.300 times 10. 4 sig figs, 10 to the third. Okay, and so on and so forth. So we have 2 sig figs here. We have 3 sig figs here. We would have 4 sig figs here. Okay. So we can be very clear on whether digits are significant or not by looking at the numbers themselves. So let's do a couple of examples, and let's do some examples of sig figs and actually involving them in calculations. So in calculations, there's a few different things we can do involving sig figs. Okay. We can do sig figs in multiplication and division. When we multiply and divide, the result has the same number of sig figs as the quantity with the least number of sig figs. So you use the least number of sig figs in your answer. So what does that look like? What do we mean least number of sig figs? So if I did something like 5 and I multiply this by 2.3. So I'm going to type that into my calculator, and I'll get something like 11.5. But is that the correct answer if I want to obey Sig Figs? I need to look at how many Sig Figs I have in each part of this problem. So 5 has 1 Sig Fig. 2.3 has 2 Sig Figs. I want the number with the least number of Sig Figs. That's going to be 1. So my answer can only have 1 Sig Fig. Right now I've got 3, so I know this isn't good. I want to get it down to 1 Sig Fig. So if I do 1 Sig Fig, this seems like it'll round to 2. This 1 would round to a 2. Right, so this should be 12. But that's 2 Sig Figs. We don't want 2 Sig Figs, we want 1. So to round this to 1 Sig Fig, I will get the answer 10. So it seems annoying, but this is truly the case. This is how calculations work for multiplication and division. Let's see another example. Let's do 630, and let's divide that by 1.50. So how many Sig Figs are in each of these? 630 has 2 Sig Figs. Again, that 0 right here, that's not counted as significant. It's counted as a placeholder. And then 1.50, because this 0 is at the end, it is significant, so that makes 3 Sig Figs. So I want my final answer to have the least accurate number of Sig Figs, least number of Sig Figs, so that's going to be 2. So I do this division problem, 630 divided by 1.5, and I get 420. Okay. And it turns out that number that pops out of the calculator, that's got 2 Sig Figs, so I'm all done. There's my final answer. So that's how we do calculations of Sig Figs when we're multiplying and dividing. Slightly different rules for when we're adding and subtracting. So when we're doing addition or subtraction, we want the least accurate decimal place. Okay, so what does that mean? That means, let's do an example. If I have 3.65 minus 1.2, I'm going to do this subtraction, and I'm going to get out 3.45, but I'm going to look at the two elements of this problem, and I see I have this number goes to the hundreds place, this number 1.2 goes to the tenths place. So this is going to be the least accurate. Okay, so my answer is going to go out to that number of decimal places. So I can only go to the least accurate. I can only go to this 10th place. So that 3.45 isn't quite right. I need to round so that I get 3.5. So there's my final answer. And let's do one more where we do, let's say, 7.365, 46. And we'll add 8.232. I look at these two numbers, I can see this is the least precise. This is only 3 decimal places, whereas this is 5 decimal places. So I do this addition problem, I get 15.59746, and you should put this into your calculator. Do these calculations. Don't just blindly copy them down. Make sure you can type them in. And I only want this to 3 decimal places, 1, 2, 3. So I'm going to round to this 3rd decimal place to get my final answer of 15.597. And that 7 is going to stay because it's next to the 4, so I don't round that up. So there is my answer for that number of Sig Figs. So that is how we do Sig Figs accuracy and precision.